In the last few sessions, we learned about the role of parser. Okay, what is the job of parser? So, parser is a software which takes input string and it will tell whether the input string is in accordance to the grammar production or not. Or we can say a parser is either accepting the string or it will reject the string. Rejection means it will display a kind of error. If it accepts the string, that implies that the string is syntactically okay. This parser are of two types, that is top-down parser and the bottom-up parser. In this particular session, we're going to discuss about the top-down parser. Now let us concentrate on the top-down parsing. So top-down parsing means it starts from the start symbol and moving down, okay, towards the input symbol. So bottom-up parsing, so it moves from input symbol to start symbol. Okay. So the top-down parsing can be viewed as an attempt to find a leftmost derivation of an input string. So in the sentential form, it will be collection of terminals and non-terminals. Leftmost derivation means starting from the left, okay, starting from the leftmost derivation is replaced with the respective production rules in the grammar. So consider this particular example and the production rules and the grammar. Let us construct a parse tree. So E derives TE dash. Then what is T? FT dash. Then what is F? IED. Then what is T dash? Replaced with epsilon. Okay, so in this way we can continue the parse. See here. So this is for the complete parse tree now. So finally F T is derived with F T dash and F is derived with IED and star FT dash bar IED epsilon E dash is finally replaced with epsilon. But look at the concept here, just go through that E dash. Okay. See, in E dash, actually we have two alternatives, right? Plus T dash or epsilon. So in that place, if I replace epsilon, why I have to choose plus T dash? I'll replace it with epsilon. So what happens? Whether I'll get correct input string? No, definitely not. Okay. So here it will introduce something called the ambiguity, right? Something like the confusion. If I select epsilon first, definitely I won't get the input string. So how to select the alternatives? Okay. So now let me explain with one more example. Okay, I'll explain the concept backtracking clearly. Look at the productions of the grammar and the input string CAD. Let me construct a parse tree. So the start symbol, what is that? S. It is replaced with CAD because we have only one production rule for the non-terminal yes. Now look at this input string C is the exact match with the C. Now we are highly optimistic that we are going to get the input symbol. That is what our hope. Let us proceed. Okay. So what we have to replace for capital A? Now we have confusion. We have two alternatives A, B, bar B. Now let me choose the first production rule, that is AB. Now look at that. CA, okay, exact match. What about B? Okay, we got input, incorrect input. Therefore, what we have to do is, we have solution here. Let us do something called the backtracking. Okay, so backtrack means one step back. In simple word, we can say backtrack means it is undo operation. Let us undo the operation and now you replace it with A. So what we'll get? We'll get the correct string now. CAD is the correct input. So now consider the recursive descent parsing. As we studied, at each step of top-down parse, the key problem is that determining the production to be applied for a non-terminal. Let us say it is capital A. Once capital A production is chosen, the rest of parsing process consisting of matching the terminal symbol in the production body with the input string. So this section begins with general form of top-down parsing called recursive descent parsing, which may require backtracking. That is to find a correct capital A production to be applied. In the later section, we'll introduce predictive parsing, a special case of recursive descent parsing where no backtracking is required. Means it will follow something called the data structure in such a way that the parser itself select the correct production for the correct input symbol. So look at this algorithm now. So what actually this algorithm explains? See, this particular algorithm actually says that we have to select the non-terminal, that is start symbol, and for each non-terminal we have to write a procedure. So in general case, let us assume it is capital A, I mean non-terminal. So what we have to do? So in this algorithm, we have to choose a production called, for A production, let us have the alternative x1, x2, etc. xk. Now you have to consider, you have to scan from left to right each symbol one at a time. So that is for I is equal to 1 to k. Suppose if you find a non-terminal, then what we have to do? We have to write a procedure for that particular non-terminal. Okay. If xi is not a non-terminal, means it is a terminal, that is xi is equal to the current input symbol A. So matching occurs and you just advance the pointer to the next symbol of input string. If not correct match, okay, we studied in the previous example. Okay, so B is not a correct match. Therefore, what we have to do? We have to conclude either we have to do the backtrack or else this is a error case. So this procedure declare it as an error. Clear? So how to modify this algorithm to implement the backtracking method? A general recursive descent may require backtracking. That is, it may require repeated scans over the input. However, backtracking is rarely needed to parse a programming language constructs. So, backtracking parser are not seen frequently. Even for situation like natural language parsing, backtracking is not very efficient and the tabular method is preferred. So, whatever is studied in dynamic programming concept. Okay. To allow backtracking, the code has to be, so this code is not modified, but where we have to modify it, let us see that. First, we cannot choose a unique capital A production at line 1 because this capital A production may have several alternatives. So what we have to do is we have to select the alternative, okay, alternative one at a time in some order. Then at failure, line 7 is not an ultimate failure. So here the correction is, instead of reporting the failure, you go to, you return to line number 1 and choose another A production. Only if there are no more A production, then you declare that an input error has been found. Clear? In order to try another A production, we need to be able to reset the input pointer to where it was when we first reached line 1. Means while scanning the input symbol, what we have to do? We have to remember the previous point. For undo operation, in order to perform this, we have to remember actually what is the previous point we stopped, because we have to set another alternative. Therefore, we have to maintain one pointer. It will remember the address of that particular non-terminal. Thus, a local variable is needed to store this input pointer for future use. In general, top-down parsing means a recursive descent. Okay, so top-down parsing called recursive descent parsing. So which may require backtracking and non-backtracking. How to handle the backtracking we just studied, and non-backtracking method. So here the predictive parser comes into picture. So what is predictive parser and what is LL parser we'll going to study in the next video. Thank you.